All right, so just to get it on the recording here, our plan is to finish the notes today or a little part of tomorrow's quiz or tomorrow's day, and then you'll have the rest of the period tomorrow to work on your worksheet. We're done, Kylie. You got about a minute left, all right? And then the worksheet will be due on Monday, and then on Monday in class you'll work on a practice test, 5.1 to 5 through 7, and then we'll test Tuesday 5.1 to 5.7, and that's spring fling is all next week. So it's going to be an exciting. We got a math test and we got events happening around campus. It's going to be exciting. So, and then Wednesday we'll start trig identities, which is leading to trig proofs. I think y'all will enjoy that. Okay. Um, oh, there is a. When is the STAR test on Tuesday?
Oh, I think we should do it on Friday.
Y'all do have the STAR test next Tuesday. Wednesday is open. Yeah, so I guess because of the STAR test, which I won't see y'all Tuesday, we'll test Wednesday.
Not this Friday.
No, you want to do this Friday? No, we'll test next Wednesday. We'll test next Wednesday. How'd you get in the door? That's a security breach. You put the lives of everybody here at risk. But it was nice of you to want to save people from getting up. I'll applaud that. All right, so we'll test Wednesday. Tuesday, I'll have the STAR. What subject is it? History? The history STAR. Okay. The STAAR. What a great way to spell STAR. Okay, to evaluate the following without a calculator, we're on example 13. Sine of arc, cosine of negative square root of 2 over 2. Okay, do these even have a chance at undoing each other? Are those inverse functions of each other? They're not inverse functions of each other. So when you have composition and they're not inverses, you actually just have to evaluate it from the inside out, right? Inside out. We do the parentheses first. So let's think to ourselves, just like we did bless you on the quiz, bless you. What is the arc cosine of negative square root of 2 over 2? What quadrant's going to be in? Quadrant 2. And what's the cosine angle or the square root of 2 over 2 is the x-coordinate? 3/4. Yeah. If you want to write the ordered pair in quadrant 2 should be negative square root of 2 halves, positive square root of 2 halves, right? That's where we are. We're over here at 3/4. Now, what's the sign of that angle? Positive square root of 2 over 2. Yeah. It's the sign of the angle whose cosine is negative square root of 2 over 2, and it's just positive square root of 2 over 2, right? So does it help to write the ordered pair, maybe? Yeah. Once I get you to an angle, this part right here is going to get you to an angle, to some theta. Once you have that theta on the unit circle, you have your ordered pair. And once you have that ordered pair, don't by now I expect you to get any one of the 6 trig functions from that ordered pair? Yes, so it doesn't even have to be sine. I could have asked you for the cotangent of arc cosine, okay? But we started easy. Arc cosine and sine of 5/3. Are these inverses of each other? Will they have a chance to undo each other? No. So if they don't undo each other, you just work it out from the inside out. Parentheses first. So we got arc cosine of sine of 5/3. What's sine of 5/3? Negative square root of 3 over 2. Very good. Very good. Now we want the arc cosine of negative square root of 3 over 2, and that's going to be in quadrant what? Quadrant 2, where cosine is negative in the PVR, and the angle is... What's the angle in quadrant 2 where the x-coordinate is negative root 3 over 2? It's got to be your pi what? Pi 6, pi thirds, or pi fourths? It's got to be pi 6. Now what is it in quadrant 2? It's 5 pi 6. There you go. There you go. You can see, you can kind of imagine your test, which will be now next Wednesday because of the STAR history test. These make great multiple choice questions, don't they? I can just do a whole string of these, like all 9 of them are just like this. And you're just like, oh, easy, 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 right? Everyone makes 100 on the test. All right, let's do this one. Inverse tangent of cosine of pi. Work it out from the inside out because inverse tangent and cosine, they're not inverses of each other. So I'm going to have the inverse tangent of, what's cosine of pi? -1, right? -1. And now what's inverse tangent of -1? No, we want the angle whose tangent is -1. That's going to be in quadrant 4, isn't it? Well, what angle is that? -π4. Right. We want the angle, not the ratio. Remember, when we take the inverse tangent of a ratio, we want the angle. Okay? When we take the tangent of an angle, we want the ratio. So the answer is -π4. All right, hold on to your bananas. Here we go with part D. Cotangent of arc sine of -√3/2. What is the arc sine of -√3/2? No, I think it's your π3 reference angle, right? And it's going to be down here in quadrant 4. It's going to be right there. So it should be -π3. If you want to write the ordered pair there, it's going to be 1/2 (-3/2). So now that I have the ordered pair there at -π3, don't I have all 6 trig functions? Yeah. Okay. So what is the cotangent? Well, if you look at your ordered pair, it's 1/(-3), which when you rationalize it is, there you go. So you're not going to miss much on the cruise. You'll be fine. Questions so far? Am I going too fast? We're explaining as we go. You'll get to practice this on your own in the worksheet. You'll get to demonstrate the mastery you acquire on the test. Tangent of sine of 2π. Now notice this one's interesting. This is not inverse tangent of sine, and it's not tangent of inverse sine. These are both trig functions, aren't they? So their inputs are both angles. Well, let's see. Let's see if it works. We got tangent of sine of 2π. What's sine of 2π? 0. It's 0 the ratio, right? Sine of the angle 2π gives us 0 the ratio. But now 0 the ratio, because it follows tangent, turns into 0 the angle. See that? And what's tangent of 0? It's 0. Tangent of 0 is 0. Tangent looks like this. It passes right through the origin. Yeah. Inch by inch, it's a cinch, right? Work it out from the inside out, step by step, piece by piece. Sine of 2π is 0. Tangent of 0 is 0. Piece cake. What if I had cosine of tangent of sine of 2π? Let's build this question up. It would now be cosine of 0, which is what? 1. See? So it doesn't matter. As long as I have things strung along the way from the inside out that pertain to the unit circle, you could just keep evaluating it, right? Layer by layer by layer. Is 1. Yeah.
Yeah, but isn't it also -1?
Not cosine of 0.
Oh.
Cosine of pi is -1. It's a function. There's only one output. What's the ordered pair at 0? Here's 0, right? Here's 0. It's 1, 0. Cosine of 0 is 1. Any other comments or questions? Does that straighten out in your head now, Brady? No, I want it to be all the way. Yeah, okay. I think you're thinking, where is cosine 0? Cosine is 0 up here. So if this were inverse cosine of 0, let's talk about that. If that were inverse cosine of 0, that would be pi halves or 3 pi halves, which is down here. But which of those is in the PVR? Pi halves. So 3 pi halves would be out. So then the answer would be pi halves instead of 1. You see, as long as I'm stringing these along layer by layer and you can work from the inside out layer by layer, you're good. Okay, y'all try this one by yourself. Secant of tangent of pi. I'm going to answer the telephone. This is Corby. I'll send, yeah, Natsu. I'll send her down. She needs to go to the back office. The library for testing. Okay, I didn't see your name on there. I overlooked it. I'm sorry. Okay, thank you. Natsu, you need to go to the library for testing. Testing. I think they're going to take like DNA and see what your lineage. I don't know what kind of testing it is. No, no, I'm joking. You're gonna have to take a written test. Um, I'm not sure what test it is. Maybe an English test or something. It's just because you're new to the country. They want to make sure that you know what you're doing. Okay. Do you know where the library is? Okay. Yeah. I think they're waiting for you. When you walk in, there'll be a large group of people there waiting for you. So don't feel embarrassed or anything. Just say, "Hey, the party has arrived. Let's get this thing started." Okay? All right. Yeah. I'm sorry. I'm recording the video, so you can just go to the point in the video where I say, "Bye, Natsu. Good luck," and you can watch it from there. Hello. Okay. Yeah. What did I get? Secant of tangent of pi. Let's see. We work from the inside out. What's tangent of pi? 0. And what's secant of 0? 1. Easy, right? Piece of cake.
Yeah. DNA test.
Oh, yeah. Well, they didn't say what type of testing. I was just kind of thinking what type of testing they could do. Drug testing, DNA testing. Inverse cosine of arcsine of 0. So notice um, the inverse cosine of arcsine, those are both inverses of each other, right? So let me work from the inside out. What is arcsine of 0? What is the angle whose sine is 0?
Uh,
Sine of what angle in the PVR is 0? 0. No, 0. 2 pi is not in the PVR. Sine of 0 is 0. Sine of 0 is 0. So arcsine of 0 is also 0. Okay. Now what's inverse cosine of 0? Where is cosine 0? No. When we say inverse cosine of 0, I want to know for what angle is the cosine 0. It's pi halves. We're shifting gears every time, right? Our brain is going from angle to ratio, angle to ratio, angle to ratio, or sometimes angle to angle, or sometimes in this case ratio to ratio. This was double ratio. Arcs. What's that? No, because negative pi halves is not in the PVR for cosine. It's up here in pi halves. But negative pi halves has a cosine value of 0. It's just not in the PVR. All right, everyone getting it? You're getting some mental pliability here. You're being able to think with agility. All right, sine of 2 times arc cosine of 0.5. 2 times arc cosine of 0.5. What's that 2 doing there? It's multiplying. So I'm just going to say 2 times whatever the arc cosine of a half is. What's arc cosine of a half? Pi thirds. Very good. Pi thirds. And now I get sine of 2 pi thirds. What's sine of 2 pi thirds? Nope. Positive square root of 3 over 2. 2 pi thirds is right here. It's the 60-degree reference angle. Whoo! This is a good workout. You know, your brain burns more calories than your feet. Yeah, yeah. Unless you're running a marathon, then your feet kind of burn a lot of calories. But your brain, when you're thinking, burns a lot of calories. So you might find yourself hungry after this. There you go. That's the kind of thinking I like. Look at this triple decker. We're not afraid of triple deckers. Secant of arctangent of sine of 3 pi halves. Inch by inch, it's a cinch, right? How do we eat the elephant? One delicious bite at a time is the answer. Elephant. This is some tasty elephant. So our first bite comes from the sine of 3 pi halves. What's sine of 3 pi halves? Not quite. It's negative 1. It's negative 1. Okay, now we take the next delicious bite of the elephant. And the secant is still out there waiting to be eaten. What's arctangent of negative 1? Negative pi fourths. Yeah, because negative 1's down here. And the ordered pair at negative pi fourths is positive square root of 2 halves, negative square root of 2 halves. We memorized it as 7 pi fourths, right? But they're coterminal. Negative pi fourths and 7 pi fourths are coterminal. So now what's the secant of negative pi fourths? It's the same as the secant of 7 pi fourths, which is what? So just square root of 2, right? What's the reciprocal of the square root of 2 over 2? Just the square root of 2. Yeah, there's your answer. Just the square root of 2. Brainy. I like that. It's a good quality. Brainy. Something you look for in a mate.
Yes.
Yeah. If y'all are searching. Y'all are still young. The possibilities are endless. But you should put brainy on the qualification list. Like before you go out on your first date, say, "Hey, can you do this? I need to see how brainy you are. Can you do that for me?" Nope. Okay, you're paying for your own Whataburger tonight then, right? Or Chick-fil-A or wherever you're going. I'm gonna sit 2 seats over from you in the movie then. I'm not quite committed. I will, right? Right. If you can't do that, then we go to the movie. Here's the movie. Here are the chairs. X, 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 the chairs. You sit here and I'll sit here. Okay? Because you didn't do this problem. Now if you were able to do that problem, I would probably sit here, if not on your lap. Okay, all right. Hey, you gotta watch the movie. Example 14. All right, so example 14 gets into what happens when we have variables instead of numbers? Well, when we have variables, we can rewrite the trig of the inverse trig as an algebraic expression, meaning there is no trig in it. No trig at all. Okay? Let me show you what I mean. Okay? You're going to like these types of problems. This, by the way, is like your free response question. You'll have them like this, all right? Cosine of arctangent of x. First of all, is x an angle or a ratio? It's a ratio. How do we know it's a ratio?
Follow the arc.
It follows an arc or an inverse. So I'm going to make it look more like a ratio by putting it over 1. Are you okay with that? Perfect. I agree. That's a perfect. So that's a ratio. Now, this is going to give me some angle theta. Yes, yes? Let's go up to the side and we'll draw just a little reference. I don't know if x is positive or negative. So I'm just going to draw something in quadrant 1. I'm going to draw something in quadrant 1 because I don't know if it's positive or negative. And there's my angle theta. Thank you. Now, because that's the tangent ratio, are you done?
I was taking, I mean, I'm taking this theory right now, and this two I'm taking English too, but
So you don't need the test? Oh, okay. Sorry for the hassle. Sorry for the hassle. All right, arctangent is what? What is the definition of arctangent in terms of x, y, and r in the unit circle? It's y over x, right? It's y over x, which is vertical over horizontal. So I'm going to label the vertical as x and the horizontal as 1. This x right here is different from the x on the unit circle. They're different, okay? I know tangent is y over x. That's vertical over horizontal. So I'm going to label my two sides of the triangle, because that's what I have when I have a ratio, x over 1. Do I know how to find the hypotenuse now? R. Yeah, because 1 squared plus x squared must equal r squared. That's the Pythagorean theorem, right? And if I solve for r, I get the square root of 1 plus x squared. There you go. Cool. Now here's what I know. I know all three sides in terms of x, or a constant. I know all three sides in terms of x. I don't really want the angle, do I? I want the what? I want the cosine ratio of that angle. Well, cosine is x over r, isn't it? So it's x over r, which is 1 over the square root of 1 plus x squared. And we're done. So we create what's called an identity. An identity means that it's a mathematical synonym. I can replace one with the other without any loss of generality. They're equivalent to each other. Okay? So this is an identity that we use in calculus. If we start with the left side and it's either too hard to work with or we're in an algebraic context, I can replace it with the right-hand side, and I can work it that way, or vice versa. If I have the right-hand side and we're in a trig context, I can change it to cosine of arctangent of x. They are equivalent to each other, right? If you plug in an x on your calculator into the left-hand side and an x into your calculator on the right-hand side, you're going to get the same answer. If you're going to graph one of them in y1 and the other one in y2, they're going to trace right over the top of each other. Is that what you're doing? Yeah. Graph this in y1, graph this in y2. I'll let you do that on your own, like Peyton just did, but they'll trace on top of each other. You get the same graph. Okay? And that's all we have to do. That's pretty easy, huh? All you got to do is draw a triangle. How hard is drawing a triangle? It's only 3 sides. It's not like I had you draw a 96-sided polygon.
Yeah.
It's only 3-sided polygon. Easy. But that's the first one you've seen, so you might be a little bit like, what the? So let's try another one. Let's try another one. Sine of inverse cosine of 2x. Is 2x an angle or a ratio? It's a ratio, so I'm going to put it over 1. And then this is going to give me some angle theta. So I'm going to come off to the side here. I'm going to draw just a little first quadrant triangle because I don't know if x is positive or negative. There's theta. And then I'm going to label the 2 sides. Cosine on the unit circle is x over r, yes? X over r, which is horizontal over hypotenuse. So I'm going to label the horizontal 2x, and I'm going to label the hypotenuse 1. That's not hard, I hope. Now I just got to find the missing side. The missing side is y. So by the Pythagorean theorem, quantity 2x squared plus y squared equals the hypotenuse squared. Would you agree? Pythagorean theorem. Make sure you square the quantity 2x. That gives us 4x squared plus y squared equals 1. And if I solve for y, I get y squared equals 1 minus 4x squared, which means y must equal the square root of 1 minus 4x squared. And I don't know if y is positive or negative, so I'm just going to keep it positive for quadrant 1. And now I have all 3 sides. I have all 3 sides in terms of x. I have all 3 sides in terms of x or a constant. So I don't really want the angle. I want the what of the angle? I want the sine ratio of the angle. Well, sine is what? Y over r. So it's the square root of 1 minus 4x squared over 1, which is really just the square root of 1 minus 4x squared. Congratulations, you created yourself another identity. All right, now we have 2 more examples to go. Part C and all of 15 where we go backwards. So this is a good place to stop. We'll warm up tomorrow with part C, which will give us kind of a reminder of how to go forward, and then we'll decompose it going backwards, and we'll finish, and then you'll have the rest of the period to work on your homework, okay? All right, you got to know your unit circle, don't you? And you got to know the PVRs. So if you don't know those yet, commit those to memory. All right.